Hi, Susan.
Christina?
You want to talk about summarizing and graphing data today?
I do. I think it's important. Let's do it.
It is pretty important, yeah. Okay, so I've got the pre-class video, which hopefully you already watched. We just wanted to remind you again to watch the pre-class video and take notes. And in that example, you were given the frequencies from this data set. So what we're going to look at today is how I could get those frequencies myself in StatCrunch using technology without going through and counting, by hand.
Yes.
Yeah, because that's not very useful if you have a large data set to go through.
500 pieces of information. It's not useful.
Right. So some characteristics when we're talking about descriptive statistics that we're interested in, are center variation, distribution, outliers, and time. Those are all important characteristics. And what the frequency distributions and their graphs, the histograms, really show us are this one right here, the distribution, okay, or the shape of the data. That is that's kind of what we're most interested in this section is how is the data look? Is it kind of symmetric, gathered toward the middle, to the left, to the right? So there's some definitions here that you'll want to read through, and we talked a little bit about those in the pre-class video. So let's scroll down to this example about literacy rates. So I want to work through these the technology tips here. Is that okay, Susan?
Oh, yeah.
Where we take this data and make a histogram and use that histogram to get the frequencies.
Because here's the deal. A frequency distribution is a table, and a histogram is a kind of a picture. They're the same information. The histogram is just a picture of the table.
Yes. And you can label the graph so that it shows you the frequencies so that you can put those in the table. So that's what we're going to do, using that value above bar in our histogram options. Okay.
Yes. So
this data here is in not one column because that would take up a lot of space on the page. So you can copy and paste this data into StatCrunch and put it in a column. Or I do have a link here that will go directly to StatCrunch. So this data set is in our group, our StatCrunch group, which you'll want to join before you start working on your Unit 1 activity next week.
But it's okay, because we give you instructions on how to join once you start the activity.
Yeah. But from your notes, you should be able to click on this link if you want to and open it in StatCrunch, and then you might be prompted to log in to StatCrunch. But I'm going to go ahead and do that. And I think I'm already logged in, so I should just be able to open it. Yep, it opened. And here it is.
So this is probably their first time seeing StatCrunch, and it looks a lot like an Excel spreadsheet.
Yep, it looks a lot like an Excel spreadsheet. And here's that data. It also has the country associated with it, but we don't need that column, that country column, for our frequency distribution. We only want the numbers column.
Right.
So our frequency distribution that we're going to make, we're going to use a class width of 10 and a lower limit of 30.0 for the first class. Okay, so the way I got those frequencies in StatCrunch was to go to histogram. And then I'm going to choose that literacy rate column. And notice it doesn't even give you the option to choose country because you can't make a histogram with nominal data.
Right.
So I'm just going to choose literacy rate. And I'm going to start at 30.
We were told the lower limit of our first class needed to be 30, and we were told to have a width of 10. So that's what we're going to tell StatCrunch that we want. This is really important. You want to do the value above the bar, because what that will do is it will force StatCrunch to count frequencies for you.
Yep. Yep. And so there's my histogram, and you can see that's where I got the frequencies. So in that first class, the frequencies 2, second class 1, 3, 3, 5, 6, 28. Okay.
Okay.
Great. And so then the rest of this is similar to what you did in the pre-class video. You're going to, total up your frequencies. There were 48 data points. So I take the frequency divided by the total to get the relative frequency. And then I'm going to get the cumulative frequency. I'm just going to add the frequency and the frequencies of any previous classes.
Yes. And it should add, you should end at 48 because that's how many you have.
Yep. And then in the notes key, I just copied and pasted that histogram in there so you can see what it looks like. We're going to talk at the end of this section of notes about the shapes of these distributions.
Oh, good.
Yeah. Yep. Okay. So another thing that we can use StatCrunch for, if I wanted to make a stem and leaf plot of kind of a large set of data, I could also use StatCrunch to help me with that. Because it will make a stem and leaf plot, but I can also just use it to sort the data if I wanted to put the data in order from least to greatest. So let's just practice that with this. Now, this data here is not in a column, and I don't have it saved anywhere. So when I put it, if I do Control-C and copy it, and then I'll just put it over here. Then I'm going to have to put it in a column because it's not automatically.
Right. Yeah.
So that can be a little bit annoying, but I'll start with the end. Let's see. How far over does it go?
I'm going to pause the recording until we get it done, okay?
Okay.
Okay.
Okay. So I got all that data into a column. And just to double check, there are 30 data values there. Okay. And then on my stem and leaf plot, since these are pretty close together, the breaking point there, and you can see in the key, is actually where the decimal point is, right?
Yes. And you always create a key for your stem and leaf.
Yeah. Yeah. So I have whole numbers there for my stems, 24 through 32. And now over here on StatCrunch, if I want to sort that data, I can go to Data and then Sort. And I don't do anything at the top. I'm going to leave that as all columns. But I'm just going to sort by variable 4 because that's where I put my information. And when I do that, my data is listed from least to greatest.
Okay. And that's why we start the stem at 24, because 24.6 is that lowest number. And I assume 32.8 is the highest one in our list.
Yes, it is.
Yep. There it is.
Yep. And so then it's real easy to see, oh, okay, so the 25s, there's two 25s, and they get a 0 and a 0 for their leaves.
That's right. Note, if there's duplicates, right, there's two 25.0s, so you're going to have a couple of zeros there. Yeah.
Yep. And then there's the 25.7, 25.8, 25.9. There's a whole bunch of 26s there, and I can just write the order 1, 2, 3, 5, 5, 6, 6, 7, 8, 8, 9, 9, right?
Okay.
And then on down the list. Yep. Good. Good. Sometimes, if you have a smaller data set, like on this one, I probably wouldn't bother putting that in StatCrunch.
No, because nobody's going to tell you how long it took her to get all that in one column.
Yeah. I would probably just look at this one and write out the stems and the leaves. So yeah. Why does this go 5, 4, 3, 2, 1 instead of 1, 2, 3, 4, 5?
Arrange the stems from highest at the top to lowest at the bottom.
Oh, I see it now. Okay. Oh, hey. Read the directions. Gotcha. Okay, a dot plot is another kind of graph here where we can see the distribution, okay, where you have one dot for each of your data values.
Right, and if you have two data values that are the same, you'll just stack the dots on top of each other.
Yeah, or 10 data values that are all the same.
Yeah, just stack them all.
Yep, and so the height of those dots is, shows you how many values you have there. In the rest of the notes for this section, there's some different kind of graphs that you might see, whether in real life or in your homework. For qualitative data, we tend to do different kinds of graphs. I can't do a histogram or a stem and leaf plot for qualitative data. So, something like a pie graph you might see, or a bar graph, where my x-axis there, instead of being numbers, are different categories, right? Yeah. And then the last thing here we want to talk about are the shapes of the distributions.
Yes.
So we have histograms here to kind of show what the different shapes are. And the first one here, symmetric, or you might see it as normal or bell-shaped, is where you have, your highest frequency is in the center, and then it kind of goes like a bell shape, where the ends have the highest frequencies on the left and the right. And then if your data is skewed to the left, that actually means that you have kind of a tail to the left. Right. And the reason it's called skewed to the left is that those lower values there are pulling your mean. You're pulling your average down.
Because they're far away from the average.
Yes.
Yeah. So look for the tail.
Yeah.
When you're identifying whether skewed to the left or skewed to the right, look where the tail is, and that's how you're going to name it. Skewed to the left, skewed to the right.
Not where the bulk of your data is. So it's kind of
right.
I think we get those confused sometimes. So, and then you could also have something that looks like it has two peaks. That's called bimodal. Okay.
Right.
And then
can we go back to those skewed just a second? Because sometimes they get a question about mode. So can we just point out which one is the mode?
Yeah. So the mode, let me zoom in a little bit. The mode would be where the highest frequency is. So this green bar here, which it looks like it
would be the mode on that one because it's the highest bar. We saw that on the bimodal, but I thought it'd be nice to, maybe take a look at it.
Yeah.
So the mode is the tallest bar.
The mode is the tallest bar. Yeah.
Because it's the one that's happening the most often.
Yeah. Yep. And then the uniform distribution is where we expect all the frequencies to be about the same.
Like rolling a fair die, you expect to get one as often as you get two, as often as you get three. So you're expecting the frequency of each of those rolls to be the same eventually.
Yep, exactly. Good. Again, read through the rest of the notes. There's some more information on here about, what makes a graph misleading, whether you're making or reading a graph. Look at different aspects there. But that's really about it. Okay.
Great. Do we have any homeworks that we're going to talk about?
Oh, yeah. Yeah, we do. I was going to, thanks.
You're welcome.
I wanted to show how to put some of these into StatCrunch, which we talked about a little bit already. Yeah. But again, when you have a data set in your homework, it probably is not going to be given to you in a column just because it takes up a lot of space. And so you, if you have a homework question like this, you probably will want to copy and paste it into StatCrunch. Okay. And then do what we did with making a histogram. Okay.
Now this all in one column, just keep copying and pasting it into one column.
So this particular homework question here, though, the data is sorted, right?
Oh, so easy. Yeah.
Yeah. So I probably this one, I probably would not take the time to put into StatCrunch because I know between 20 and 29, I'm going to have a frequency of 2, right?
Yeah.
And then 30 to 39, looks like I've got 1, 2, 3, 4, 5, 6, right? So this particular data set, I probably would not copy and paste into StatCrunch since it's sorted. But I do think that you should do what we did with the literacy rate data and copy and paste it in there and sort it or make the histogram if it's not already sorted.
Yeah.
Okay. So I would do that in question, let's see, 11. Yeah, like this data set, I would put it into StatCrunch and sort it.
Because they're not in order. Yeah.
Because they're not in order. Yep.
Okay.
Yep.
But since it's only asking about the 90s, I might be tempted to just look at the 90s and create it because the rest of it's there. Yeah.
Yeah. If I had to make the whole stem and leaf plot.
Oh, yeah.
I think I would want to sort it, but yeah. I don't think there's any other homework I wanted to look at. I just wanted to point out that when the data is already sorted, it's faster to not put it in StatCrunch.
Okay.
Okay.
All right. That's it.
Yep.
Okay. Next time.
See you next time.